Hello dear students, hope you are all doing well. I'm back again with another video lesson. If you remember, in a previous lesson we talked about the sound wave. Sound is a mechanical longitudinal wave, which is particles vibrating parallel to the direction of the waves. And also we talked about the types of the sound wave. We had three different types of the sound wave: infrasonic, ultrasonic wave, and audible sound wave. And also we talked about the pitch, which is directly proportional to the frequency. More pitch has more frequency and less wavelength. Okay, and when we talked about the pitch, according the definition of the pitch is a subjective quality that depends on the listener. Okay, more pitch has more frequency. When the pitch changes, the frequency and the wavelength also changes. Okay. Today's lesson, in section 1, chapter 4, we are talking about sound waves propagate in 3 dimensions. Okay, what is the spherical wave? Spherical waves are emitted from a single point. Okay, spherical waves are emitted from what? A single point source, or any source in a spherical shape. According to its name, the spherical wave, the shape of the spherical wave is sphere. Okay, but in great distance, this shape from sphere changes to plane. Okay, straight. In a great distance from the source, can be approximated with parallel planes known as a plane wave. What is spherical wave and what is plane wave? For example, if we have a sound source, okay, this sound source produces the sound wave. Okay, in a small distance, this wave, the shape of this wave is a spherical wave, as known in a spherical wave. But in a great distance, in a more distance, when distance increases, what happens to the spherical wave? The spherical wave becomes plane wave. As you can see in this figure, for example, assume that this is source. This is the sound source. What is this? Sound source. Okay. In a small distance, the shape of the wave is spherical. Look. The shape of the wave is what? Is spherical. But in a great distance, as you can see, in a great distance, the shape of the wave becomes what? Almost parallel to each other. When does the sound wave becomes plane wave? In a great distance. When does the sound wave becomes spherical wave? In a short distance. Right? Plane waves can be treated as a one-dimensional waves, all traveling in the same direction. And we have a question here: why, when the sound is produced in the middle of the room, this sound can be heard throughout the room? For example, when I'm talking with my students, even when I look at the whiteboard and the students are located in my back, at this point, at this direction, the students, they are still hearing when I'm talking. Why? Because the sound wave spread out or traveling in all directions, not only in one direction. Okay, when someone is talking, this sound is propagated in all directions as a shape of spherical wave, because the sound wave spread out in all directions. In which direction? In what direction? In all directions. For example, if this point is a sound source, okay, this sound is produced in all directions in the shape of spherical wave. We have some notes about the spherical wave and sound wave. Sound wave actually travels away from a vibrating source in all 3 dimensions. Sound waves spread out in all directions. The waves front of sound waves spreading in 3 dimensions are approximately spherical wave in a short distance, and the spherical waves can be represented graphically in 2 dimensions with a series of surrounding the source as shown in the figure below. Okay, what are these circles? This is wavefront. The wavefront of the sound wave, in a small distance, this wave becomes a spherical wave, but in a great distance, this wave becomes parallel. And the circles, each circle, look, each circle of this source, the sound source, represent for what? Compression. Okay, this is sound source and this is wavefront. What is this circle? This is wavefront. Okay, and the circle represent what? The center of compression. The center of the circle represent for what? Compression. And the compression, if you represent the compression as a sine wave, it will be like that. Okay, guys, what is this? This is the center of the circle. The center of the circle is represent for what? Compression. And compression in a sound waves represents as a crease. Like when we studied, can we represent the sound wave? Sound wave is longitudinal wave. Okay, it has compression and rarefaction. Can we represent this compression and rarefaction as a sine curve? Yes, of course. How? Compression corresponds for the crease and rarefaction corresponds for the trough. The circle represents the center of compression, call it the wavefront. Each wavefront located at the center of compression. So the distance between two adjacent wavefront is equal to one wavelength. The distance between two wavefront, this distance is equal to how many wavelengths? One wavelength. So what about the distance between three wavefront? We have two wavelengths. 1 plus 1, 2 wavelengths. Can we say that the distance between two wavefront is equal to one wavelength? Yes, of course. Distance between 5 wavefront, 4 wavelengths. So we can write an equation, lambda wavelength is equal to wavefront minus 1? Yes, of course. Okay. For example, if we have 30 wavefronts, wavelength is equal to what? Is equal to 29. So the radial lines are perpendicular to the wavefronts are called the rays. Okay, so this is the ray. Okay, these rays are perpendicular to what? Perpendicular to the wavefronts. Any small portion of a spherical wave that is far from the source can be considered as a plane wave. When does the spherical wave become a plane wave? Far from the center, far from the source. The spherical wave in a great distance becomes plane wave. Plane waves can be treated as a one-dimensional wave, all traveling in the same direction. So we have two types of wave: spherical wave, plane wave. When does the sound produces the spherical wave? In a small distance, but in a great distance, the sound wave becomes plane wave. Wavefront and plane wave. Wavefront, what is wavefront? The circles represent the center of compression. It's called wavefront. As you can see here, guys, look. What is this circle? The circle is wavefront. How many wavefront do we have here? We have 3 wavefront as an example. Okay, the distance between any 2 wavefronts is equal to 1 wavelength. Plane wave. Any small portion of the spherical wave that is far from the source is called a plane wave. Now we have another topic in this section. Breaking the sound barrier. It's very important and it has been brought in the Wizari exam many times. This is very important. Pay close attention, please. What is shock wave? Waves that are caused by strong and sudden disturbance of pressure and density and the temperature, as happens on an airplane. The shock waves happens with what? With the airplane. Okay. Look at this 3 cases. We have 3 cases. The first case, when the speed of the plane less than speed of sound. The second case, when the speed of the plane is equal to speed of sound. The last case, when the speed of the plane is bigger than speed of sound. Now we will talk one by one in detail. What happens to the planes when the plane's velocity is less than the sound wave? In that case, it creates a disturbance in the air pressure. So this disturbance is spread in the front of the plane at a speed of sound, while the plane follows them at a less speed and nothing happens. Okay, so nothing happens in that case when the v plane is smaller than v of speed of sound, because this is plane. Okay, the disturbance is produced in the front of the plane and nothing happens here. Okay, the second one, guys, when the plane when the speed of the plane is equal to the speed of sound, in that case when the plane attains the speed of sound, the disturbance will accumulate in the front of the plane, creating a shock wave. Guys, look, listen carefully. When does the shock wave is created? When the velocity of the plane is equal to the speed of sound. When the speed of plane is equal to what? Speed of sound. In the case when the speed of the airplane reaches or attains the speed of sound, in that case the shock wave is created. But when speed of the plane less than the speed of sound, does the shock wave create? No, the shock wave does not create. Nothing happens when the speed of the plane less than speed of sound. But when the speed of the plane is equal to speed of sound, in that case the disturbance will accumulate in the front of the plane and creating what? Shock wave. This is called what? The airplane reaches the sound barrier. Reaches the sound barrier. Let me ask you a question. When does the plane reaches the sound barrier? When the speed of the plane is equal to the speed of sound. When does the shock wave is created? When the speed of the plane is equal to speed of sound. And the wavefront becomes flat wavefront. The wavefront here is spherical wavefront, but here this is plane. Okay, this is the airplane. The wavefront becomes what? Flat. Okay, what is this? This is wavefront. Guys, when does the wavefront becomes flat wavefront? When the speed of the plane reaches the speed of sound. In that case, the wavefront becomes flat wavefront and it is perpendicular to the direction of the plane wave. This is the direction of the plane wave and this is the wavefront. Wavefront becomes perpendicular to the direction of the wave and it will be perpendicular to the direction of the speed of the plane. The last case, when the speed of the plane is bigger than the speed of sound. In that case, when the speed of the plane exceeds the speed of sound, when the speed of the plane exceeds the speed of sound, the shock wave will form. What is produced here? The shock wave. Okay, guys, in both cases, when speed of the plane is equal to speed of sound or when the speed of the plane exceeds the speed of sound, in both cases, shock wave is created. Okay, in both cases, shock wave is created. For example, if I ask you, when does the shock wave is created in the airplane? When the speed of the plane equal to speed of sound or when the speed of the plane bigger than the speed of sound? Both. Both are correct. In both cases, the shock wave is created. Okay, but what is the difference between these two cases? The difference is that this shock wave forms at the edge of the plane, okay, and superposed to give a huge explosion that reaches the ground and breaking the sound barrier. Breaking what? Breaking the sound barrier. Can we say when the speed of the plane is bigger than the speed of sound, the plane breaking the sound barrier? Yes, of course. But when the speed of the plane reaches the speed of sound or equal, in that case, the plane does not breaking the sound barrier. Instead, reaches the sound barrier. The difference is what? When speed of plane equal to speed of sound, the plane reaches the sound barrier, but when speed of the plane bigger than speed of sound, the plane breaking the sound barrier. In which of the following the plane breaking the sound barrier when the speed of sound bigger than, when the speed of the plane, sorry, when the speed of the plane greater than speed of sound. In that case, the plane breaking the sound barrier. By a plane gives rise to a huge amount of the energy that made breaks the window panes and window panels, and sometimes the plane breaks sound barrier. Okay, but guys, the wavefront in the case when speed of the plane equal to speed of sound, wavefront is perpendicular to the direction of the planes, but when the speed of the plane greater than speed of sound, the wavefront shape becomes conical. This is not flat, okay? This wall has broken when the speed of the plane exceeds the speed of sound, and the shape of the wavefront, what is this? This is wavefront. The shape of the wavefront becomes what? Conical shape, okay? What is this shape? Is a conical shape. Okay guys, look at this video about the shock wave in the airplane. As I told you, when the speed of the plane is less than the speed of the sound wave, nothing happens, and the disturbance will accumulate in the front of the plane as the shape of the spherical wave, and the shock wave is not produced, and the plane does not reach the sound barrier and does not breaking the sound barrier. We can say nothing happens in that case, as you can see in this video. Guys, look, in this case, the speed of the plane is less than speed of sound. The sound wave will accumulate in the front of the plane. Nothing happens, no creating shock wave, not breaking sound barrier, okay? Just the wave accumulate in the front of the plane. This is the first case, when the plane's speed less than speed of sound. But in this case, look, now you can see, look, in this case, guys, look, the speed of the plane reaches the speed of sound. When the speed of the plane attains the speed of sound, the shock waves becomes plane wave, okay? And we can say the plane reaches the sound barrier but does not break. Be careful. Once again, listen carefully. When the speed of the plane reaches the sound wave, in that case, the shock wave is produced. The plane creating what? Is creating the shock wave in the front of the plane, and the shock wave becomes what? Becomes plane wave. When does the shock wave becomes plane wave? When the speed of the plane attains the speed of sound. When the speed of the plane is equal to speed of sound. Look. It is very clear and a very good video to understand well, okay? The last case, guys, this case, as you can see, the speed of the plane exceeds the speed of sound. It means that when the speed of the plane is greater than the speed of sound, in that case, the plane creating the shock wave also, and breaking the sound barrier is produced by the plane. We can say the plane is breaking the sound barrier. When the speed of the plane exceeds the speed of sound. And the wave will accumulate at the edge of the plane's wave. Okay? The waves accumulate at the edge of the plane wave, and the shape of the wavefront becomes conical. Becomes what? Becomes conical. When does the plane breaking the sound barrier? You have to say when the speed of the plane is bigger than speed of sound. When does the plane creating shock wave? In two cases. When the speed of the plane greater than speed of sound, or when the speed of the plane is equal to speed of sound. When does the shock wave becomes conical? The wavefront becomes conical when the speed of the plane greater than speed of sound. Okay. Let's go back to our topic about the breaking the sound barrier and creating a shock wave. Okay, guys. I hope you understood very well because it is very important. We have two questions here. When does the plane reaches sound barrier? Reaches sound barrier, guys. When the plane speed equal to speed of sound. So what about when does the plane breaks the sound barrier? Breaking the sound barrier when the speed of the plane greater than speed of sound wave. And look at these two notes. The shock wave front will be flat. When does the shock wave becomes flat wave front? When the speed of the plane is equal to speed of sound. So the shock wave front will be conical. When does it becomes conical wave front? When the speed of the plane is bigger than speed of sound. And as you know, the conceptual challenge are skipped. It's not including for the Wizari exam. These two questions are skipped. Okay. Now we will talk about the Doppler effect. Another topic in this section, section 1 in chapter 4. Very good topic. Be careful. Doppler effect. It is very, very important, guys. Every year they will bring the question about the Doppler effect. Okay. What is the Doppler effect? The Doppler effect is named for the Austrian physicist Christian Doppler, was the first scientist who discovered this phenomenon in 1803 and 1853, who first described it. Okay. What is the Doppler effect? The definition of Doppler effect. What is Doppler effect? An observed change in frequency. Once again, listen carefully. What is Doppler effect? Observed change. Observed change of what? Observed change in frequency. When the frequency changes, decrease or increase, can we say we have Doppler effect? Yes, of course. When there is a relative motion, but in the condition, which condition? When there is a relative motion between what? Source of waves and an observer. What do you mean by relative motion? It means that there must be a different velocity between the two objects. Okay? For example, if two objects at rest, do we have any relative motion between these two objects? No. Doppler effect will not occur? No, will not occur. When does the Doppler effect will occur? When there is a relative motion. Relative motion between what? Between observer and the source. Okay? When does we have relative motion? If two objects approach to each other, or if the observer and listener approaches to each other, or if the observer and listener moves away to each other, or if the observer and listener are moving in the same direction. Moving in what? In the same direction, but different velocity, guys. But with different speed. What about if the listener and the source are moving together? Same speed, same direction. Does the Doppler effect will occur? Never. The Doppler effect can never occur if the listener and the observer are moving in the same direction with the same speed. But if they are moving in the same direction but with different speed, yes, we have Doppler effect. So this is the equation of Doppler effect. Frequency f prime, which is the heard frequency, the frequency of the observer when the observer hears the frequency, this f prime is called the heard frequency by the observer, is equal to the frequency of the source, f, absolute f. What is absolute f? Frequency of the source, times v, speed of sound in the air, minus v, o, v, s. What do you mean by this two v? Speed of sound in the air, constant. What about VO? The speed of the observer. Speed of what? Observer. What is this? Speed of observer. What about VS? Speed of source. Velocity of the source or velocity of the observer. F prime, heard frequency by the observer. Apparent frequency, sometimes it's called apparent frequency. F, absolute F, is the source's frequency, original frequency. VO, observer speed. VS, speed of the source. V, absolute V without O and S, the speed of sound in the air. Okay? The Doppler effect will occur like, for example, when this ambulance, it is siren, it's walking, when the ambulance is moving toward this man, okay? What is this? This is source, guys. What is this?
This is the source of the sound. When the sirens is stuck by the ambulance, okay, and the ambulance is moving toward the observer is at rest. Speed of the observer is 0. And the speed of source, Vs, is approaching to the observer. Do we have relative motion between this man and the ambulance? Yes, of course. Why? Because the man is at rest and the observer, the source is approaches to the man. When the source approaches to the observer, does the Doppler effect occur? Yes, of course, it occurs. Okay? So, but the heat frequency F prime by the observer becomes more or less. The prime frequency or the heat frequency gets higher. Why the heat frequency gets higher? Because the source approaches to the observer. So, can we say that when the source approaches to the observer, the heat frequency gets higher? Yes, of course. So, what about this woman? When the source moves away from the woman, do we have relative motion between the woman and the source? Absolutely, there is a relative motion. Because relative motion does not mean when the source approaches to the observer. In the case when the force is moves, like this is observer and this is source. When the source moves away from the observer, what happened to the heat frequency? The heat frequency drops. The heat frequency decreases according to the Doppler effect. Okay? But guys, here frequency gets higher, but here frequency gets lower. So what about the frequency of the source? Frequency of the source does not change. In the Doppler effect, the frequency of the source is constant, but the heat frequency by the observer changes. It varies. Sometimes gets higher, sometimes gets lower. It depends on the motion between the source and the observer. Look at this video about the Doppler effect. Okay, sorry guys. Doppler effect, yes. Look at this video.
Doppler effect and applications.
Not this one, sorry.
As a result, any of is the relationship between frequency and pitch.
We have another video, guys. Look, not this one, sorry. I'm looking for another video about the Doppler effect. I don't know which one. Okay, I think this one. Okay, guys, look at this video about the Doppler effect.
The illustration shown here will help you understand the Doppler effect. I'm sure you would have heard an ambulance speeding past you. That is,
guys, these are observer. They are standing on the bus station. Okay,
the pitch of the sound
they are waiting for the bus.
As the ambulance approaches you, and the pitch decreases while the ambulance moves away from you.
Look, when the ambulance approaches this observer, what happens to the heat frequency by the observer? The heat frequency gets higher. Okay? Look. So, what about when the ambulance passes by the observer and moves away from the observer? We feel that the heat frequency drops, gets lower. Look.
There is a similar apparent change in the pitch of the sound.
Guys, in this case, when you saw it, when the ambulance approaches to the observer, the heat frequency gets higher. So, can we say when the source approaches to the observer, the heat frequency becomes greater? Yes, of course. So, what about when the ambulance passes by the observer, moves away from the observer, the heat frequency drops and gets lower. So, the Doppler effect occurred in this case. Another case, if the source is at rest, when the ambulance is stopped or parked, okay, and its siren is still working, but the observer is moves toward the ambulance, what happened to the heat frequency? The heat frequency increases, gets higher. But when the observer passes by the ambulance or moves away from the ambulance, the hair frequency drops and gets lower. Also, the Doppler effect will occur. Look.
When the source of sound is at rest and the listener moves towards or away from the source.
Look. So, when a man is moving away from the source, the hair frequency drops. But when the observer approaches to the source, the hair frequency increased or gets higher.
Due to a shift in the frequency of the sound waves. Based on these observations and
so this is Doppler.
J.C. Doppler proposed the Doppler effect in 1842. According to the Doppler effect, the apparent change in wavelength of sound or light is due to the motion of the source, observer, or both. Doppler effect is observed in light also.
Okay, in the light wave also the Doppler effect it will occur, so it means that the Doppler effect it will apply only for the sound wave. No, the Doppler effect it can be applied for all types of the wave, mechanical wave and electromagnetic wave. Okay, so the Doppler effect it can be applied for the light wave, yes, can be applied for all types of the waves such as mechanical wave or electromagnetic wave. Let's go back to our pamphlet. Guys, this is the Doppler effect. If you understood well, sorry. No, this card. Sorry, guys. Okay. Is the Doppler effect applies only to the sound wave? No, as I told you, as I mentioned, the Doppler effect is applied to all types of wave, including electromagnetic and mechanical wave. Why the sound of the source increases as it approaches and decreases as it moves away, although the frequency of the source does not change. Frequency of the source does not change. In the case of approaching the source to the observer, what happened to the hair frequency? The hair frequency increases, okay? But when the car moves away from the observer, as you can see, the frequency gets lower. F prime in that case gets higher, but F prime in the case of moved away becomes lower. So this change in the frequency occurs as a result of relative what? Relative motion. Without relative motion, the Doppler effect will not occur. Moving away or approaches due to the change in the wavelength of the hair sound according to the fundamental wavelength. We have some notes about the Doppler effect. The Doppler effect is not occurred if an observer and source of the sound remain at rest. Like, for example, if the source and the observer at rest, like ambulance and the observer, both of them at rest, there is no motion. In that case, the Doppler effect does not occur. The change of the frequency does not observe it because there is no relative motion between them. There is no motion between them. When does the Doppler effect will occur? In the presence of the relative motion between the observer and the source. Only when the observer and the source are at rest, the Doppler effect not occur? No. In the case when they are moving in the same direction with the same speed, the Doppler effect will also not occur. Why? Because when the observer and the source are moving together in the same direction with the same speed, there will be no relative motion between the observer and the source. Not agree? Observer and the source remain at rest with respect to each other, or, guys, look, both observer and source of the sound are moving what? With the same velocity and same direction on a straight path. Number two, the Doppler effect occurs in the following case. 1, 2, 3, 4, 5. A, B, C, D, E. In these 5 cases, the Doppler effect will occur. The first case, if the source approaches or moves away from the listener. When the source approach or move away from the listener, the Doppler effect will occur. The second case, if the listener approaches or moves away from the source. But here, V observer is 0, but here V source is 0. When the listener approaches or moves away from the source. C, if they both approaches from each other, observer and source, they both approaches to what? To each other. The Doppler effect will occur. D, if they both move away. What do you mean by move away? It means that observer and source move away from each other. The hair frequency by the observer gets lower. The last one, if they both move is in the same direction. Look at the last one. It is very important. Pay close attention, guys. If they both move in the same direction, observer and source are moving in the same direction, but different what? Different velocity. When V observer is not equal to V source, in that case, the Doppler effect also will occur. Okay? Number 3, the frequency of the source remain constant, does not change. Why? Because frequency changes by changing source only. When does frequency changes? When the source changes. When the ambulance's siren is stuck by the driver, in that case, the frequency of the siren does not change. This frequency is constant. But only the frequency here by the observer changes, which is F prime. When the observer at rest, V naught is equal to what? 0. When the source at rest, V is equal to 0. If both observer and source at rest, stop at both of them at rest, VO 0, VS 0, F prime is equal to F source, and there is no change in frequency here. If F prime, guys, when does F prime equal to F frequency of the source? When the velocity of the observer is equal to velocity of the source, and no Doppler effect will occur. No Doppler effect will occur, okay? And the Doppler effect is not occur. In the case of approaching, observer and source approach to each other, F prime is equal to what? F V plus VO, V minus VS. The sign is very important, guys. Now, I'm gonna draw about how can you put the sign of the Doppler equation. This is the main equation of Doppler effect. F prime is equal to what? F times V minus V naught, V minus Vs. Guys, this is the main equation, okay? What is this? This is main equation. The main equation of the Doppler effect, F prime, here frequency is equal to frequency of the source, speed of sound in the air minus speed of the observer, speed of sound in the air minus speed of the source. But the sign will be changes. For example, in the case approaching observer and source to each other, when observer and source are approaching to each other, this is source and this is observer, okay? Write down here at first S and O, okay? You have to write S and O, okay? Be with me, please. When we say source and observer are moving to each other, toward each other, guys, you know that when the object is moving in this direction, this is positive direction. What is this? This is positive direction. But when the object is moving to the left, this is what? This is negative direction. This is positive and this is negative. When the object is moving to the right, it means that the object is moving in positive direction. When the object is moving to the left, it means that the object has negative sign. When we say source approach to the observer, source approach to the observer, okay? So the arrow is directed to which direction? Right or left? Right. It means that Vs must be positive. Why? Because the source approaches to the observer and observer also approaches to the source. Observer approach to what? To the source. The arrow of the observer is directed to left. VO becomes what? Becomes left. Okay? Guys, in this case, as you can see here, source and observer are moving toward each other. When the source and observer are moving toward each other, the equation of the Doppler effect will be like that. F prime, F times V minus, VO is positive or negative? Negative. Why? Because it is directed to the left. Negative VO divided by V source, the source approach. This arrow is directed to the positive. Becomes what? Positive VS. Bring down F prime. F negative times negative, positive VO. Negative times positive, negative VS. So the equation of the Doppler effect is equal to F prime is equal to F times V plus V naught, V minus Vs. When does this equation will be like that? When the source and observer are moving toward each other. As you can see here, look, guys, I indicated here. In the case approaching, moving toward each other, observer and source to each other, the equation becomes like that. V plus V naught over V minus Vs. Did you understand? I hope you understood. Another case, when in the case moving away, observer and source moves away, the main equation F prime is equal to F times V minus VO, V minus Vs. In the case when observer and source are moving away from each other, moving away separately to each other, okay? As I told you, at first we have to write down source and observer. Source and what? Observer. This is source, this is observer. When they are moving away from each other, it means that the source is moving in this direction. This direction is positive or negative? This is negative, to the left. Okay? And the observer is moving to the right. Okay? Source, observer. When they are moving away from each other, VO is directed to left or right? VO is directed to right. Positive or negative? Positive. But VS moves away is negative. VO also moves away. They are moving away from each other. VS becomes negative because the arrow of the VS is directed to the left and the arrow of the observer is directed to the right. So the equation will be like that. F prime, F times V minus V minus. Look, for the observer is positive or negative? Positive, VO. Source, negative VS. Bring down the F prime, F times negative times positive, negative VO. Negative times negative, positive VS. The denominator becomes positive, the denominator becomes negative. When does F prime, according to the Doppler effect, is equal to the frequency of the source times V minus V naught over V plus Vs? In the case when observer and source they are moving away. Source moves away to each other. Moves away. Source in this direction and observer in this direction. The equation becomes what? F times V become V naught, V plus Vs. Okay? This is the second configuration of the Doppler effect. The third one, guys, look at the third one. Note number 8, if the source and observer are moving with the same direction. Guys, this is very, very important. Pay close attention. The two previous cases when we talked in the Doppler effect, the first case approaching to each other, the second case moving in opposite direction away to each other. But in this case, this is completely different. Both source and observer are moving with the same direction. With what? With the same direction, but not with the same velocity. Okay, this case can be classified into two types. If the observer goes ahead. What do you mean by if the observer goes ahead? It means that when the source following to the observer. Okay? In that case, guys, look, source, observer, source and observer. Okay? When they are moving in the same direction, but observer goes ahead. What do you mean by observer? It means that the observer is moving in this direction and the source is following to the observer. This is same direction, okay? V source becomes positive to the right, and V observer also becomes positive, okay? In that case, both the observer and the sources are moving in the same direction, but in that case, when the observer goes ahead, the equation of the Doppler effect, it becomes like that: F times V minus V naught, V minus Vs. Bring down this. F times V minus V minus. Guys, for the observer, the velocity of the observer positive V naught, positive Vs. It becomes what? F prime, F times negative times positive, negative VO, negative Vs. When does F prime is equal to F times V minus V naught, V minus Vs? When source and observer are moving with the same direction, but the observer goes ahead. Okay, it means that the source is moving in the back of the observer and the observer is moving in the front of the source. When the observer is moving in the front of the source. But what about if the source goes ahead, or if the observer is moving to the in this direction? Okay, when the source goes ahead, okay, but the previous case the observer was going to ahead, but here the car goes ahead. The equation of the Doppler effect, it becomes V plus V naught, V plus Vs. As you can see here, S and observer, okay? When the source goes ahead, Vs becomes negative, Vo also becomes negative. In this case, the Doppler effect, F prime, this is main equation, V minus V naught, V minus Vs, F prime is equal to F times V minus Vs, Vo negative, negative Vo, Vs also negative Vs, negative times negative becomes positive, F times V plus V naught, V plus Vs. When does this equation can be used? If the source and the observer are moving in the same direction but different velocity and the source goes ahead. Okay, guys, that's all for today. Inshallah, in the next lesson we will continue explaining the Doppler effect and we're going to solve all questions that related with the Doppler effect, and inshallah we will finish section 1 in the next lesson. Thank you for listening. Keep up your best doing. Have a good time.